So here we go. This is the square off. So this is for another $500 and a chance at a $2,000 bonus question. All right. And Nolan is not sharing any of that high performance drink. He's going over. So as we call it, the square off question. And here we go. How many minutes after 12 o'clock will the minute hand and hour hand of a clock first be at right angles? And so this is a clock where the hands are moving continuously, and not a digital clock. It's one with the hands. And here are the choices. Is it A, 15 minutes, B, 900 over 59 minutes, C, 360 over 23 minutes, D, 225 over 14 minutes, or E, 180 over 11 minutes? If you have any questions about the question, feel free to ask. Nolan? Need your answer?
E.
Is he correct? Okay, all right. Here we go for $2,000. A circle of radius lowercase r is inscribed in a square, which is itself inscribed in a circle of radius capital R. We'll let p sub 1 be the ratio of the area of the red region, pictured here, which is outside the circle and inside the square. That p1 will be the ratio of that area to the area of the entire square. And we'll have p sub 2 be the ratio of the area of the blue region, which is inside the big circle and outside the square, to the area of the entire outer circle. Which of the following is true? A, p sub 1 is bigger than p sub 2, regardless of lowercase r. B, p sub 1 is less than p sub 2, regardless of lowercase r. C, p sub 1 is bigger than p sub 2 until it's r little lowercase r all the time, until r equals square root of 2, then p sub 2 is bigger, or D, p sub 1 is less than p sub 2 until lowercase r equals square root of 2, and then p sub 1 is bigger. It looks like you understand the question?
Yeah.
All right, you got 3 minutes. Oh, we got it. All right, so for $2,000, let's see if it is B. It is!
So it's independent of R because all the R's are cancelled out. Okay.
Yeah, so tell us about how you figured it out.
All right, so if the inner circle has a radius of r, then you can see that the side length of the red square would have a side length of 2r. So because the diagonal of the square is the hypotenuse of a 45, 45, 90 triangle, then it would have a length of 2 times root 2r. So if that is the diameter also of the big blue circle, then the big blue circle has a radius of root 2r. So then you can do the area of the big circle minus the area of the red square to figure out P2, and you can put that over the whole blue square area, which would be 2 pi r squared. And then you can do that and then that would already be your P2. And then for P1, you would do the area of the red square, so that would be 4r squared minus the area of the yellow circle, so pi r squared. And then when you do the two ratios, then, I mean, I just kind of estimated that it would be less than, just kind of like doing a rough estimating to the first decimal point based on pi. Then it would be less.
So like you were saying, a lot of those r squares.
Right, all the r squares would cancel out because every term in the final equation would have an r squared next to it, so it's independent of r. So already I eliminated c and d automatically, but then when I re-looked at it, I forgot to set up the ratio with the sine length of the square and the sine length of and the area of the blue circle originally. But it turns out that the area of the blue circle being bigger than the area of the square, I didn't really have to worry because that only increased the difference between the proportions.
So that's pretty good. Nice going, Nolan. You get $2,000. So here, Nolan, they have a certificate from the university here. That's much better than a check. Who needs a check now? And as we say in the math game show industry, Nolan, your check is in the mail. But we have...